Hello everyone, and welcome to 7th grade math, module 3, expressions and equations. In this video, we're looking at lesson 21, surface area. Our learning goal is to make sure we can calculate the surface area of three-dimensional figures. This will help us to master standard 7GB6, solve real-world and mathematical problems involving area, volume, and surface area of two- and three-dimensional objects composed of triangles, quadrilaterals, polygons, cubes, and right prisms. In this lesson, we're going to be using our formula for surface area of polygonal prisms, which is P, which is the perimeter of the base, times W, which is the distance between the two bases of the prism, plus 2 times B, which is the area of that base. Surface area is the area of all the combined surfaces of a 3D shape. We can find it by using that formula, which is a shorthand way of trying to find the area of all of the flat surfaces on the outside of our shape. Because it's difficult to visualize a 3D figure in a two-dimensional format like a paper or a screen, we can use nets to give a representation of all of the surfaces of our 3D shapes. For all of our prisms, our net ends up making the two bases of our prism, and then all of the lateral faces of our prism end up making a longer rectangle altogether. The perimeter of our base ends up being the length of that longer rectangle created by the net of our prisms. So that is where our formula for surface area of a prism comes from. So let's try to use a net and our formula to try to find the surface area of a rectangular prism with side lengths of 3, 4, and 6 inches. The first thing I did with this three-dimensional shape is I drew a two-dimensional net so that I could see all of the outside surfaces on my screen. In order to use my surface area formula, I need to find the perimeter, the width, which is the distance between my bases, and then the area of my base. To find my perimeter, I have highlighted that in teal. So the perimeter is the outside of my gray shaded rectangular base. So all I need to do is add up the four sides of that base. So 4 plus 6 plus 4 plus 6 gets us 20 inches for the perimeter of that rectangular base. Note that when we look at the net, the length of the large rectangle made by my lateral sides is the perimeter of our base when it is folded up into its 3D form. Next, I need the width. The width is going to be the distance between my two rectangular bases. So in this case, that would be the 3 inches. After that, we need to find the area of our base. Since this is a rectangular prism, we can use the formula for the area of a rectangle from our formula sheet, which is base times height. And then we just take the base of 6 and the height of 4 and multiply them together to get 24 inches square for the area of our rectangular bases. So then how do we put all these together to find our surface area? We're going to take our perimeter of 20 inches and multiply it by our width of 3 inches to find the area of that large rectangle we get from all the unfolded side faces. Then we're going to do 2 times the area of our base because there are two bases in our shape. When we do this, we end up with 60 plus 48, which gives us 108 square inches for all of the square surfaces of this shape. Marcus thinks that the surface area of the right triangular prism to the side here will be half that of the right rectangular prism. If we notice in the picture here, this is the same rectangular prism, but it's been sliced in half to make a rectangular prism. So do we agree that our surface area would be half if we cut our shape in half? Let's use some nets to find out. You can pause the video here to try to find the surface area of this triangular prism on your own, and then check your work with the video. First, we need to find the perimeter of our triangular base, which in this case would still be the length of that unfolded rectangle in our net. To do this, we just add up the three sides of our triangle, 3, 4, and 5, to find our perimeter of 12 inches. Our width would then be the distance between the two triangular bases, which is the 6 from our diagram. Finally, we need to find the area of our base, the area of a triangle. So first we need to take our area formula for a triangle, half base times height. Then we can replace the b and h with the base and height of our triangle, 3 and 4. Once we have that, we can then multiply it together to find that the area of our triangle is 6 inches square. So now that we have all this, we can plug it into our surface area formula. Our perimeter of 12 times the distance between our bases of 6 plus 2 times the area of our two triangular bases, which is 6. So when we multiply all that together and then add, we find that the area, the surface area of a right triangular prism is 84 inches square, which is significantly more than 54 square inches. And if you think about it, it makes sense. While we did cut the prism in half to create this new shape, we made one more surface than was on our rectangular prism. A piece that was previously on the inside was now on the outside. So our surface area would end up being that much more than half of the original surface area. Now we're looking at a slightly different type of prism. This would be a circular prism, or as we commonly refer to it, a cylinder. If we take this cylinder and unfold it, and in fact at places unroll it, we still end up with a net that has 2 of our base and then a long rectangle for the lateral side. So you can pause the video here and try to use the same strategy for those other prisms to find the surface area of this cylinder. First, we need to find the perimeter of our circular base. We already know that the perimeter of a circle is its circumference. So first, you can calculate the circumference by doing 2 times pi times our radius of 3, which gets us 6 pi centimeters for the circumference or perimeter of our circle. Next, we need the width, which is the distance between the two circular bases. That distance is 2. Then we need the area of our base, the area of our circle. So we need to do pi times radius squared, or pi times 3 squared, which gets us an area of 9 pi centimeters squared. Now that we have all of those, we can put them into our surface area formula. We can even keep it in terms of pi. So we take our perimeter of 6 pi, multiply it by our width of 2 centimeters. And then we're going to add that to 2 times the area of our two circular bases, 9 pi. And when we do that, we take 12 pi, the area of the rectangle in our net, plus 18 pi, the areas of both of the circles, to find the area of the whole surface of the cylinder to be 30 pi centimeters square. What does this video make you wonder about finding the surface area of prisms? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.